अरे फोन किए थे तो आप।
Okay, write down, all of you write down the third question. Next question, that is to convert, to implement a MATLAB program, a MATLAB code for discrete cosine transformation of an image. Okay, discrete cosine transformation of an image. First, let me. Yes. Ah, if the screen is visible to all of you, if the screen is visible,
Yes, sir.
okay. So as I already discussed in the class, now this is the mathematical formula. Okay. So this is a mathematical formula to convert a image to the frequency domain while using the DCT, discrete Fourier transformation. So what will happen? So the actual image is represented in case of this one two real components of cosine format. Now you can see for this is for first real component, okay, in the cosine format, or this is my second real component in the cosine format. Fine, now this is my actual image. Then there are two constants we are using, alpha k and alpha l. Okay, the value of this will be alpha k will be, if k equal to 0, it will be root over 1 by capital N. Fine, if k equal to not equal to 0, that means it is greater than or equal to 1, then it will be root over 2 by N. Okay, similarly, alpha l ka value will be same for two constants. So while using these two formula, if you want to calculate, so this formula will be used. Uh, uh, so if you want to calculate, now suppose this is, now suppose you want to compute, okay. Now if for n equal to 4, now compute a discrete cosine transformation matrix for n equal to 4. If you take the, like we have computed the Fourier transformer for different size of matrix, n equal to 4, 8, 16. Similarly, if you want to compute a discrete Fourier transformer n equal to 4, okay. So how we can calculate mathematically? This is the process. This is the process you have to calculate. Now what first you have to do? Now I will substitute the value of n equal to 4. Now it will be 0 to n. Okay, it will be 0 to n and we'll start from 0 up to 3. Okay. Now for one dimensional, we are calculating for a one dimensional. So this is the formula for one dimensional. ठीक है, तो हम लोग क्या कर रहे हैं, n इक्वल टू 0 से लेकर 3 तक चलाएंगे, x ऑफ n लेंगे वैल्यू, ओके, 2n plus 1 5k by 8. By substituting k equal to 0, k equal to 1, k equal to 2, k equal to 3, k equal to 3 तक substitute करके find करेंगे. Now while substituting k equal to 0, what we will get? Now we will get this value. When k equal to 0, we know that the value of alpha k will be 1. Value of alpha k will root over 1 by n, which is 1 by 4. That's why it is 1 by 4. ठीक है, summation 0 to 3 तक xn n के जगह 4 लिखना है, ठीक है, n के जगह 4 फिर फाइन. तो ये हो गया आपका x ऑफ 0 का वैल्यू निकाल सकते हैं ना, x ऑफ 0 का वैल्यू will be something this one. Similarly I will find x of 1. Okay, similarly I can find x of 2 and x of 3. ठीक है. Now if you design the coefficient matrix will be something like that. So this coefficient matrix. So this is the coefficient matrix for n equal to 4. This is coefficient matrix for n equal to 4. n equal to 4. Cosine matrix हम लोगों ने डिजाइन किया था. The main objective of this one is to design a cosine matrix. So actually when you convert this one, so when you convert to DCT, so how actually you convert in? So we are having a cosine matrix, okay, cosine matrix into the original image. I will take the original image. Fine. Then I will multiply this with cosine matrix transformation. Similarly, हम लोग जैसे FTP पे करते थे. Fine. Fourier transform से किए थे ना हम लोग. यहाँ पर भी ऐसे the coefficient matrix into image, then transformation of coefficient matrix. Okay. So now we will. Now this is mathematically how we are solving mathematically. Now what we will do? So we will perform we will write a MATLAB code. Okay, we will write a MATLAB code to find the cosine matrix or design the different cosine matrix of this, and when n equal to 4. Okay, for n equal to 4, we will find the different cosine matrix. Right, we will tell different cosine matrix for that. Okay. So let me show you. So I will clear the screen so you will see, and I will clear the workshop also. So I will use clear all command to clear my on the workshop. Okay. Now, with the clear also. So we can use to derive a DCT matrix. We can use DCT math function for 4. What actually is the output? Now you can see the output. So what actually it is derived? Now it is given a coefficient matrix. Okay, it is given a coefficient matrix for n equal to 4. Fine. So what we get that this is a function. Okay, DCC mat is a function. Okay, which is basically used for designing a coefficient matrix. So now this will be derived a coefficient matrix. Okay, coefficient matrix of size 4. Now this result, now you can see that the result is equivalent to what we have get mathematically. जो हम लोगों ने मैथमेटिकली सॉल्व किया था, यहाँ पर आप लिखोगे ये जो आया है आपका कोफिशिएंट, दिस इज नथिंग बट दिस मैट्रिक्स. ठीक है नहीं? You can compare the values are 0.5, 0.5, 0.5, 0.5. You can also see that the values are 0.5, 0.5, 0.5, 0.5. Now next values you can compare this value with the same. It will be equivalent. Okay. So this is a MATLAB function. This is a MATLAB function which basically calculate the coefficient matrix for size equal to 4. Okay, so do remember this function dct math. Okay, math. So now let us write the MATLAB code for the uh, DCT transformation to convert any image using DCT. Fine. So this is the program which is which will convert to your any image to the frequency domain with the help of DCT. So I have taken an image. Suppose now a matrix. Suppose I'm taking an input matrix. Okay. So now this is suppose the basis matrix of taking basis matrix. Okay. So it will automatically take the basic matrix by the input command. So input is a function. Okay. Now remember input is a function which will be used to take input from the keyboard. Okay. Input from the keyboard के लिए input function हम लोग use करते हैं. तो आप यहाँ पर matrix input basic matrix आप वहाँ पर दे सकते हैं. So whatever matrix you will store, it is going to store in it. And okay. Now I'm calculating alpha values. Okay. Alpha 2 and alpha 1. Now alpha k and alpha L हम लोग निकाल रहे हैं. So what is alpha 2? It is nothing but 1 upon 1 by n into square root of 2 by n. Okay, when n k equal to 0, if k is not equal to 0, and when k equal to 0, it will be square root of 1 by n. Fine. Similarly, I am calculating the L values, same formula. Okay. Now what we have done, now we have taken, this is my actual formula. I am writing the actual formula. Then your converted image will be in UV format. Okay. Then it will be alpha of u plus 1. This actually we are writing the formula. That of course a mathematical formula that is written in this manner. Fine. Once this is converted, now once it will be converted, now we can display the image. So if you run this program, okay, if I run this program, you can see the output, what output you are getting. So let me run for this. So you can identify what output. So let me write, let me call the function which is so DCT. So it is asking enter the basis matrix. Suppose I want to draw the basics matrix for 4. Okay, basis matrix for 4. Now you can see what you will get. So the output will be in this manner. So what is this? This figure basically shows a basis matrix. So what we represented there, it is represented in a Fourier coefficient manner. Okay, Fourier cosine history transform 4 basis matrix for n equal to 4. This is a basic matrix. Okay, the image basically show a basic matrix for n equal to 4. Similarly, if you want to find for different values, okay, now suppose you want to find for different values, we call this function again. Okay, now suppose I want for n equal to 8. Now you can see what is the difference here when I write n equal to 8. So the basis matrix dimension of 8. Now, yeah. Now you can see what it is given. Now these are the figure which is showing that it is a basic matrix for n equal to 8. Now the basic matrix for n equal to 8. Fine. So write down this. Here, this thing. Write down this program. All of you write down this program. Or let me say, let me copy this one and save it also. you can write down this one, okay, as it is opening, taking some bit of time. So you can write from here. So all of you have to implement this problems, okay, the three problems. I will upload an LMS assignment for today's lab, okay. I will upload an assignment. So you have to write in a lab copy and implement this program and take the screenshot of these programs and upload in the LMS portal. Fine.
Excuse me, sir. हेलो
हाँ पूछिए.
जैसे अगर मैं रन करके स्क्रीनशॉट डालती हूँ तो वो नहीं चलेगा, मीन्स लैब कॉपी में लिखना मैंडेटरी है.
लैब कॉपी में आपको जब कॉलेज खुलेगा ना ऑफलाइन, ठीक है,
हाँ
आप लोग को सबमिट करना पड़ेगा लैब कॉपी. तो उस टाइम तो आपको लिखना ही पड़ेगा, ठीक है. तो इसलिए अभी
पता
से
नहीं सर खुलेगा कि नहीं खुलेगा, इसका गारंटी तो नहीं है ना. मीन्स अभी तो प्रैक्टिकल कर रही हूँ तो अभी तो स्क्रीनशॉट लेके मीन्स कर ही सकती हूँ, मतलब अपलोड तो कर सकती
अभी के लिए ठीक है, अभी के लिए ठीक है, स्क्रीनशॉट लेके आप कर रहे हैं, ठीक है, दैट इज
हाँ.
गुड. लेकिन अगर इनके लैब खुला, फाइन,
हाँ.
देन यू हैव टू
हाँ.
सबमिट द लैब कॉपी. देन उस
ओके
टाइम
सर.
एक्सक्यूज भी नहीं दे सकते हैं कि सर इतना सारा लिखना है. इसलिए मैं बोला अभी से अगर लिखोगे तो उस टाइम बर्डन नहीं, because this of this year, so as we have got the MBA accredited, okay, so for every lab we have to maintain the lab copies. This is a mandatory rule. तो
ओके
आपको लैब कॉपी देना ही पड़ेगा. ठीक है. सो लेट मी सेव द बुक से.
सर वो प्रोग्राम रन हो गया सर.
क्या इमेज आ रहा
हाँ
है
सर,
अगर
लेकिन उसमें हाँ आ रहा है सर, सब सही है. बट उसमें कंफ्यूजन है कि आप डिवाइड किए ना 255, वो डिवाइड क्यों कर रहे हैं? मीन्स आपने कहा कि वो ग्रे स्केल
डिवाइड
के लिए हाँ ग्रे स्केल इमेज के लिए कन्वर्ट करने के लिए कर रहे हैं, बट वो नहीं हो रहा है, मुझे अलग से वो करना पड़ रहा.
आपको कन्वर्ट क्या करता है डिवाइड बाय 255 करने से. इतनी राइट है मैट्रिक्स टेक्स्ट लेते हैं. एक्चुअली क्या करेगा ना, जो वो ब्लैक में कन्वर्ट करते तो जितने भी 255 वैल्यूज होंगे ना, जितने भी 255 होते हैं ना, दैट विल बी कन्वर्टेड टू. Okay, so when I divide this one by this division or other division, that's the school. ठीक है. अगर ये इमेज लगा अभी, ओके, तो अगर हम इसको एंटर करें तो क्या आ रहा है वैल्यूज. नाउ कैन सी द वैल्यूज. अगर हम वैल्यूज देखेंगे, फर्स्ट का वैल्यू देखो, इट इज 165, 161, 165, 55. ठीक है. नाउ अब इसको अगर हम लोग डिवाइड करते हैं, सपोज आई एम नाउ डिवाइडिंग बाय 255 and if you see the now the values are what we have. Now actually हर एक कंपोनेंट को हम लोग डिवाइड कर देते हैं, रिलेशन को डिक्रीज कर देते हैं. पर अगर वो डिवाइड नहीं करेंगे तो काम नहीं कर रहा था.
हाँ वो व्हाइट स्क्रीन आ रहा है, मीन्स ज्यादा व्हाइट ही आ रहा है.
वाइट ही सारा है.
हाँ
समझे?
यस सर
तो बेसिकली वो हर एक एलिमेंट को 255 से डिवाइड करना है। पहले हम लोग गैस के लिमिट ले रहे हैं, हम लोग को पता है गैस के लिमिट का रेंज कितना है, 0 to 255, तो मैक्सिमम जो वैल्यू होगा 255 का, तो वो उसका मैक्सिमम वैल्यू से हर एक पिक्सल का इंटेंसिटी को डिवाइड कर देता है। ठीक
ताकि
है,
डार्क इमेज शो हो,
हाँ,
अदरवाइज इमेज शो ही नहीं होगा। हाँ
सो ही नहीं हो रहा है, लेकिन डार्क इमेज इंटेंसिटी उसका कम कर देगा। फाइन,
यस गॉट इट यस सर।
ओके, जस्ट सेव द कोड। ओके, सो मैंने कोड सेव किया अभी। ट्राई टू रन दैट कोड। क्या आ रहा है नाउ? Yes, the output is something like that. Yes or no? Okay, is it over? Is it completed?
यस सर हो गया।
Yeah.
हाँ
ओके, एक छोटा सा प्रोग्राम आप करते हैं। हम लोगों ने आरजीबी में कन्वर्ट किया था, लेकिन आरजीबी कंपोनेंट में। नाउ सपोज इफ द कंपोनेंट्स आर गिवन, देन हाउ टू गेट बैक द ओरिजिनल इमेज? आरजीबी कहाँ गया? RGB So now my question is, write down the question. Now convert the read an image, then convert to different component and reconstruct the image. Reconstruct the image while using the MATLAB function. By using the MATLAB function. Fine. So first you have to convert in different components. So let me convert it. This is my first component. Copy. So let me store this component as a name of the variable. Now let's store this as red. Okay. Red equal to this is my red component. You can see that this is my red component. Then blue component. Component. मुझे क्या करना है इसको? Find component. Then there is a green component. क्या करना है? Value will be green. Okay, so we have converted in different components. Now if I want to reconstruct, अगर original image चाहिए तो कैसे लाएंगे? The original image can be found image equal to, I will use the cat command. Cat three component number of कितने combine करना है, three component. Now I'll give the component name. One is red, okay. What we given image cat three red, blue, and green. It's combined. Now can if I show the image, so I am show. Okay, I am show this cat command is equal to cat three red, blue, and green. Fine. This is red component value. It is blue. Okay, but it is not on getting the original image. What actually cat command is doing? The cat command is converting. Okay, converting to the different component. Okay, instead of writing individually. So what actually doing instead of writing I am so like that. If you use the cat command, okay, if I use the cat command, it will uh, convert the different component, right? Image one, then image two, then image three. This is red component, blue and green component. With the help cat now cat command concatenation of array. Okay, basically it's the concatenation of array. So concatenate the array A and B along the dimensional BI. Now if you write cat to AB is same as AB, and if you write cat is same as AB. Fine. If you write like this, concatenation input array dimension, and use comma. For example, why the answer is not. Three component, if we have red component separately and if you want to create a color image, then we use concatenation function. Yes, we have used concatenation function, but it's not working. I am so not. Okay, fine. We will see this program in next class. Okay. So what we have to do today's assignment. So first of all, you have to complete these questions. Okay. Question number. What questions are there? Let me show you the questions once again. Yes. So what you have to do now? First, you have to write this question. Okay. First question is now to take two images, then interchange the face. Okay, face of two images, and study the difference between this one. Second question you have to write is now write a MATLAB program for converting a color image to read a color image and convert to the grayscale image. And fourth question is write a MATLAB command to read an image and resize the image to 256 cross 256. To take any image of a higher dimension, then you have to convert it. Now you have to use the resize command. Okay, resize command to resize the images. And finally, write a command to read a color image. The fourth program for today's is color image and find the different component of the image. Then fifth command, the fifth program we have written to implement the basis function. Now fifth question is to implement the basis function for DST for n equal to 4. Okay, so we have to write the basis function, basic functions. Okay, basic function for DCT when n equal to 4 and n equal to 8. Okay, n equal to 4 और n equal to 8 का आपका बेसिस फंक्शन को डिराइव करना है in DCT. Fine, these are the 5 questions. So you have to implement these 5 questions. Okay, and once you implement it, you have to upload in LMS portal. Okay, so I will create an assignment there. So you have to upload this question. Okay, so any doubt? Anyone having any doubt regarding this? Yes, any doubt? You are having any doubt? Okay, if you are not having any, yes, go on.
Actually, I have already uploaded all the questions except 7 one.
ठीक है,
Except
already
7 number question.
7 नंबर क्वेश्चन क्या था? ये फेस चेंज वाला?
हाँ, वो मैंने अपलोड. यस सर.
ठीक है, लेकिन कैसे अपलोड किया? मैं तो क्रिएट नहीं किया असाइनमेंट अभी तक. किसमें अपलोड किया?
नहीं सर, आपने आपने किया था 4 नंबर असाइनमेंट 4. ये क्वेश्चंस थे ना
अच्छा, ये
असाइनमेंट 4
क्वेश्चन
में
पिछले दिन. ठीक है,
है. हाँ
फाइन फाइन. गुड गुड.
हाँ, मुझे 7 समझ नहीं आया तो मैंने नहीं किया वो वाला
Okay,
क्वेश्चन.
fine. Then you upload the 7th question and the basis function for DST. Fine,
ओके सर.
DST.
ओके सर.
Okay, anyone?
थैंक यू
Other?
सर.
और किसी का डाउट है कुछ? Okay, fine. Then if you're not having any doubts, so this is the end of today's session. Okay. So in the next session, we will see some of the pre-processing image. Okay, image pre-processing पढ़ेंगे, जिसमें हम लोग पढ़ेंगे image segmentation, then noise remover पढ़ेंगे हम लोग, how to remove the noise from the images while using the low pass filter and high pass filter. Okay, then how to invert an image. Okay, then how to find the complement of an image. So these are the program that we will going to perform in our next lab, which is comes under the topic called image enhancement. Okay, and image enhancement technique. Fine. So thank you for participation. So I will stop the class here.
इसमें से
हाँ, बोलिए बोलिए.
सर जो असाइनमेंट नंबर 4 है वो
हाँ.
तुमका वाले स्टूडेंट भी करेंगे क्या, ऐसा कुछ?
आपका तो नहीं है ना LMS पोर्टल में. ठीक है, लेकिन आप लोग भी इम्प्लीमेंट कीजिएगा, लेकिन सबमिट नहीं करिए, लेकिन आप लोग इम्प्लीमेंट करके रखिए. फाइन, क्योंकि कुछ इंस्ट्रक्ट, क्योंकि आप लोग LMS लॉगिन नहीं कर पाओगे ना, क्योंकि आप लोग रजिस्टर नहीं होंगे.
हाँ हाँ हाँ.
वो इशू आएगा. लेकिन इम्प्लीमेंट करो, इम्प्लीमेंट करने से आपको आएगा. और लैब रिपोर्ट लिख के रखिए, क्योंकि आपके कॉलेज में शायद मांग आपको लैब. फाइन.
तो सर ये जो पीडीएफ है सर उसको अपलोड कर दीजिएगा सर, या व्हाट्सएप पे डाल दीजिएगा.
दिस इज अ बुक. ओके, ये तो पीडीएफ क्वेश्चन वाला ना.
ये सर, ये सर.
अच्छा ठीक है, हम आपके व्हाट्सएप कर देते हैं क्वेश्चन. ठीक है, ओके, ठीक है.
थैंक यू सर.
ओके फाइन, थैंक यू वेरी मच.